This is my project on chemical bonding and the matrix. First, let's find out what holds atoms together in a bond. Let's say these guys are crazy atoms throwing electrons at another atom. Which is Neo? Okay, Neo is filled with protons which are attracting the other atom's electrons, and his hands represent his own electrons, counteracting with the ones moving toward him. At this point, the negative forces of the electrons and the positive forces of the protons have balanced out so that the electrons, or bullets, stay in their relative position.
That's a nice trick.
Yeah, it was. Awesome. In the last clip, Neo's hands were protons and the blades were electrons. Electrons are again negatively charged and protons are positively charged. And like opposite sides of a magnet, these particles readily attracted. The strength of that certain element to pull in electrons is called the electronegativity. The higher it is, the more it will pull. The electronegativity difference of the two elements forming a compound determine what kind of bond it is and its specific strength. Now that you know the basics, enjoy this short clip. Now, Neo is a very selfish atom, more specifically a fluorine atom, and he wants the electrons of the elements around him. The weapons represent the electrons he needs to become the one double gas. Let's see if he gets it. Ouch, he got that electron. Being the most electronegative element on the periodic table, he was bound to get what he wanted. In this video, you can imagine these ghostly figures as being a covalent bonded compound. And since these bonds are weak, it takes a low temperature to have them in a gaseous state, hence the way they seem to evaporate into thin air.
I cannot go back. I'll handle them.
Being very much solid, Neo in this image is a compound made up of strong ionic bonds, still solid in room temperature unlike the ghosts. So when comparing covalent to ionic bonds have a much stronger molecular cohesion with their matching elements.